Solving linear equations. Properties of equality. You need to get yourself familiar with these properties and name. The first one, here we have reflective property, means A is equal to A. That's pretty obvious. A is equal to A. The name of this property to support that is called reflective property. Number two, symmetric property. If A is equal to B, then B is equal to A. That's pretty obvious too. Transitive property. If A is equal to B, then B is equal to C, then A is equal to C. That should be pretty obvious also. So these were the properties of equalities. Combine like terms. Like terms are terms that have the same variables with the same exponents. That's exactly the same. So AB and AC are not like terms. You can look at some examples. Like terms. Negative 3x, 8x, minus 1/3 x. All of these are like terms. Next one, 6w squared minus 12w squared, these are all like terms. The ones that are not like terms are like x and x squared. They look kind of alike, but they're not the like terms. You cannot add them, you cannot subtract them. So 6xy and 2xyz, they are not like terms. Combining like terms, this would be an example. If I have 5a plus 7a, I can combine these two to 12a. It's kind of like I have 5 apples and 7 apples, so I'm going to add them up to 12 apples. That's pretty simple. Distributive property. For any real numbers A, B, and C, then we have A, then we have open parentheses, B plus C, we close the parentheses. You can write this as AB plus AC. You can distribute that. So this would be an example. If I have 3 outside the parentheses, I can distribute that and write it as 3x plus 3 times 5 would be 15. Now, I've seen a lot of time students combine these two together. Somehow they change it to 18x. They're not like terms. You cannot combine terms that are not alike. So if this is x, this must be x also in order to be able to combine them. Simplifying an expression, you use the distributive property to remove any parentheses and combine like terms. So if I have 3 times x plus y plus 2y, I can distribute this 3. I get 3x plus 3y, and then I have 2y here. Now I can combine like terms. I have 2 like terms here, 3y and 2y. That adds up to 5y. I'm going to write this 3x right next to that. They're not like terms anymore. Solve linear equations. A linear equation in one variable is an equation that can be written in a form ax plus b is equal to c, where a, b, and c are real numbers, and a cannot be equal to 0. So this would be an example of linear equation. The solution to an equation is the number that, when substituted for a variable, makes the equation a true statement. So we always have to check and see if what we solve is a true solution. Additional property of equality: if A is equal to B, then A plus C is equal to B plus C. This is really, really important property that allows us to solve equations. It says if A is equal to B, then I can add any number to both sides of the equation. So this would be a good example here. X minus y is equal to negative 10. If I want to solve this for x, I need to isolate x. So I need to add 4 to both sides of the equation. If I add 4 to both sides of the equation, then I would get x is equal to negative 10 plus 4, which is equal to negative 6. So negative 6 is the solution. You can check your answer, plug it back into for x. You get negative 6 minus 4 is equal to negative 10. Multiplication property of equality. If a is equal to b, then ax is equal to bx. This is also a very important property because it allows us to solve equations. I'm allowed to multiply any number I want to both sides of the equation. This would be a good example. 12y is equal to 15. Okay, I want to eliminate this 12. This is the coefficient of my variable y. To eliminate 12, I need to multiply 12 by its reciprocal. What's the reciprocal of 12? 1 over 12, right? If I have a over b, the reciprocal of that is what? B over a. Now, when I multiply a number times this reciprocal, you notice that I would get 1 as a result. So in this case, the coefficient is 12, or 12 over 1. Its reciprocal is 1 over 12. If I multiply any number times reciprocal, I would get 1 as a result. So there I have it. 1 over 12 times 12, that gives me just 1. 1 times y, that's how I would isolate y. So on the other side, I get 15 times 1 over 12. I can reduce that to 5/4. Take a look at another example. Solve the equation. Negative 1 over 4x equal to 3/4. Look what we're trying to do. We're trying to isolate x. To do that, I need to eliminate the coefficient minus 1 over 4. What's the reciprocal of this? Would be negative 4 over 1. Don't forget the negative. Some of you just said 4. Would be negative 4 over 1, right? Because we also want to eliminate that minus. So now this would be equal to 1. So that's why I need to multiply the both sides of the equation here by negative 4 times negative 1 over 4. That would give me 1. Does that make sense? So we'll multiply both of the equation by negative 4. So here we get x equal to negative 3 when I reduce this. I can check my answer. Negative 1/4 times negative 3 is equal to 3/4. Solve linear equations. These are the steps that we can follow. We can clear fractions, simplify each side separately, isolate the variable, and solve for the variable and check. These are the steps we take to solve. Take a look at a couple examples here. Here we want to solve for x. We have 2x plus 9 equal to 14. Well, we don't have any fraction here to clear. We're going to look at some examples that we do have some, but right now we don't, so we can skip this first step. Simplify each side separately. Well, there's nothing to simplify here. We can combine or distribute, so we can kind of skip the second step here. Isolate the variable. Here I can isolate the variable. To isolate the variable, I need to get rid of this 9. I need to eliminate 9. How do I eliminate 9? I would add minus 9 to both sides of the equation, or subtract 9 from both sides of the equation. So we get 2x equal to 5. 14 minus 9 would be 5. If I divide both sides of the equation here by 2, or multiply both sides of the equation by reciprocal of 2, which is 1/2, just different way to look at it, then I would get x equal to 5 over 2. And don't forget to check the answer. Always check it. Take a look at another example here. Here we have 5 minus 2a over 3 is equal to minus 9. Okay, step number 1 is clear fraction. I can clear fraction. How do I clear a fraction? Multiply this here by 3. If I multiply each term by 3, I can eliminate this 3. I have to multiply each term by 3 now. I multiply this by 3, 5 by 3, the second term by 3, negative 9 by 3, so I have to divide each term by 3. So if I multiply the first term by 3, I get 15. 3 times 5 would be 15. If I multiply the second term by 3, I would get negative 2a and minus 27. Now this is a really powerful method for more complex equations that we're going to look at later. Every time you see a fraction, you want to eliminate the fraction by multiplying each term by, this is also known as LCD, or least common denominator, right? You need to multiply each term by least common denominator. The least common denominator among all these 3 terms is just 3. If I multiply each term by 3, I can eliminate that. So once you do that, now we need to isolate the variable. You need to eliminate 15. I'm going to subtract 15 from both sides of the equation. And then I need to eliminate this coefficient negative 2, multiply both sides by the reciprocal of that, or divide both sides by negative 2. Then I can get a is equal to 21.